In this video, we'll take a look at how to solve a trigonometric equation using an identity. So we're going to solve the equation 7 times the sine of 2t minus the sine of t is equal to 0 for all solutions between 0 and 2 pi. So since the equation contains sine 2t, we want to substitute an equivalent expression that equals the sine of 2t. So we use our double angle identity for sine from section 9.3. So the sine of a double angle, 2 times theta, is equal to 2 times the sine of theta times the cosine theta. So let's rewrite our equation then that substitutes our expression in for the sine 2t. So I get 7 times, instead of sine 2t, I'm going to have 2 times the sine t times cosine t minus the sine t is equal to 0. All right, so what we want to do now is, let's multiply 7 times 2 and we get 14 times the sine of t times the cosine of t minus the sine of t is equal to 0. Now we can factor. So this helped us substituting that identity because now both of our expressions have sine t in common. So I'm going to factor out the sine of t. I'm left with 14 times the cosine t minus 1 is equal to 0. Now set each of our expressions equal to 0. So the sine of t is equal to 0, and 14 times the cosine t minus 1 is equal to 0. Add 1 to both sides, divide both sides by 14. We get the cosine of t is equal to 1/14. So our solution is going to be the places around the unit circle, basically, where we have 0 here, pi over 2, pi, 3 pi over 2. First of all, we want to know around the unit circle, where is the sine equal to 0? So the inverse sine of 0 are going to be our angle measures for t, and we want to make sure we're in radians. So if you look at the unit circle, we want to recognize that on the unit circle, cosine is the x-coordinate, sine is the y-coordinate. So we want to know the places around the unit circle where the y-coordinate is 0. So the y-coordinate is 0 right here at the beginning at 0 or 2 pi, but we're having the interval from 0 not including 2 pi, and then the y-coordinate is 0 again here at pi. So the two answers associated with the sine is equal to 0 is our angle t is equal to 0 and pi. Now we want to figure out where the cosine is 1/14. So we're finding the inverse cosine of 1/14 to figure out our angle measure t. Okay, so that's not a value that's on our unit circle, so we're going to have to use a calculator for this one. So I'm going to go ahead and use the Desmos. Let's see, I want to use Desmos, or use your TI calculator. So I'm going to get Desmos and open up the scientific calculator. All right, and let me bring it over. So here's the Desmos calculator. I want to make sure that I'm in radians, so make sure your calculator is in radians, and I want the inverse cosine of 1/14. All right. So the inverse cosine of 1/14 gives me 1.499 in radian measure. So the first place on the unit circle, or from 0 to 2 pi, is 1.499. And that's in radians. So let's see, 0, pi over 2 is about 1.57 in decimal. So 1.499 is here, this angle measure. So there's another place around the circle that the cosine is equal to 1.499, and that place is, where is the cosine positive? So the cosine is a positive in the first quadrant and the fourth quadrant. So that's a reference angle here for the fourth quadrant, 1.499. So to find the other angle in standard position from here to here is 2 pi minus 1.499 is the other place where your angle is 1/14. So we get our calculator, 2 pi, let me clear. So 2 pi minus 1.499, and that equals about 4.784. So we have 4 solutions to our equation. The angle measures are 0, pi, approximately 1.499, and approximately 4.784.